what Toyota asked to do was come in and design and build an AGV for them that would move their resin back doors from one part of their facilities internally to another part. Through that process, again, we talked about a structured system specification process earlier. We built this spec. So it started off with one vehicle. This was back in 2020, I think the first one was, with a 3-ton capacity, where to keep up with the takt on the production line, we needed to do up to 2 meters a second. We had to go through doors, fast acting doors, a traffic light system, and run a key critical part, run their 10-hour shifts continuously. So 10 hours continuous operation. Then we had a very quick shift change to roll out, roll in, swap out another battery with the capacity to run another 10 hours. These machines can be doing up to 12 to 15,000 miles per year. So they're really high usage, heavy duty applications. The solution we came up with has a high level 360 navigation scanner, which allows us to travel faster because we can look further, make better use of their facilities, and it improves the accuracy. It's a fully touchless system. So at the start of the shift, when they press go, they don't touch the system for 10 hours. We drive up with this smart train system behind, talk to equipment, we tell it we've arrived, collect a new set of doors, release the empty trays, drive out to the line, as I said, through traffic lights and doors, get to the line. On the way to the line, we are telling the operators when we will arrive. If we're ahead of if the line slows down or if it stops, and rather than get up to the line and wait and block a potential route, we will hold in holding bays, and then we will get called through to the line when they need the delivery of the doors. And all of this has been a real journey of evolution. So it starts off with a simple brief and a pretty straightforward system specification that has evolved to something that, when you look at it now, we're really proud of the system and also how we've worked with Toyota to develop it. If you perhaps jump on to the next slide, Matt. But the other part that our second slide covers with this case study, it's not all about the system specification you built to at the start. A huge part of a successful AGV application is how you install it and the process of installation. So for us, the key things here are that it's a structured process. It's how we like to work, not just defining the vehicle, but setting out the way in which we'll install an AGV system. This one, as I said, the final solution is extremely integrated into all of their operations, and it works seamlessly around their site. But to get there, we've been through a phased approach. So we started off running with a standard train system to prove out the route, and then we would introduce the smart cart system, but you'd have someone driving it around, so we kind of validate both parts of the system. Then we'd run it through various test integrations, we'd run trial shifts, then we'd run it into full production shifts, and then we'd have full production shift with an operator monitoring it. And you just go through lots and lots of installation steps to get to that final product. And the benefit of that is the two teams work really well together. We know each other's expertise for continuing to support the machine into the future. And you get lots of wins and along the process of seeing you successfully achieving milestones to get to that final solution. So yeah, my key takeaway here is designing and building a great AGV is fantastic, but the installation process is equally important, should have the due care and attention.